I will present a work done with Stéphane Cardon and Éric Jacopin at the Research Center of the French Military Academy of Saint-Cyr. Our purpose is to determine how to use music to vary player performances. And today, I will report on the use of music tempo to vary player performance. To keep a player in the flow, the difficulty of the game is usually adjusted with some variables like enemy's strength. But can the manipulation of the game soundtrack and especially its tempo allow to adjust the difficulty? Music can influence action speed, the physical exhaustion felt, driving speed and stress, stimuli evaluation, response times, and memory performance. So, we can expect that the tempo influences player performance. For our experiments, we choose to implement a game of Tetris named Tetris. Tetris is widely known. It is easy to play but hard to master, and previous studies give us information on performance metrics and standard behavior of players. We use the Unity game engine and the WISE professional sound engine to develop dynamic music which can be very precisely synchronized with the gameplay. Tetris is available on Windows, macOS and Android. You can test the application online at this address. We wanted to assess the effects of tempo variation and effect of its synchronization with gameplay elements. To be able to synchronize perfectly music with gameplay, we enforced the frame rate to 60 frames per second and designed 12 levels with tetriminos falling from every 60 frames to every 5 frames. We designed 4 stages for our game. Each stage is a session with the same 12 speed levels but not the same tempo settings. The details of the settings are the following. In stage 1, the tempo increases at each level and is perfectly synchronized with the game speed. Each pulse corresponds to a falling movement of the tetrimino. In stage 2, the tempo increases at each line, and we suppose it should prepare the player to the game speed increase of the next level. In stage 3, the tempo is increased with one level of delay and is then slightly desynchronized. In stage 4, the tempo is also one level late, desynchronized, but steadily increasing each line. We assumed that the difficulty of the game would increase with the desynchronization of the soundtrack. It would slow down players' movements and would lead them to be overtaken by the speed of the tetriminos. To be able to synchronize the music with the gameplay of Tetris requires to speed up the tempo considerably. To achieve this without damaging the aesthetics of the music, we choose to change the pulse when the verse returns. The tempo of the music is divided by 2, but the pulse is doubled. The listener has the feeling of a continuous acceleration. An enrichment of the bass and ornaments in the melody allows the listener to focus on this pulse. We collected data from 44 cadets from the French Military Academy of Saint-Cyr. Half of them play a musical instrument or consider themselves music lovers, and half of them frequently play video games. They first play a training session without music and answer a general survey including a question about their knowledge of Tetris. Then, they played the 4 stages presented in a random order to avoid any learning effect and answered a survey including questions about their appreciation of the music, their concentration, or the difficulty encountered. We collected a total of 46 series of 4 stages played in a random order. 34 participants gave us free feedback by email. We analyzed the performance of the players by considering the number of completed lines. No significant difference in performance is visible overall in each stage taken separately, which confirms the results of a previous study by Lawrence published in 2012. However, examining the results for different categories of players according to their knowledge of Tetris and their appreciation of the music shows that stage 2, where the tempo is synchronized with gameplay, is significantly more difficult than stage 4, for players with a moderate knowledge of Tetris and a neutral appreciation of the music. The analysis shows that the performance differential is greater for some stage sequences. The difference in performance is much greater when stage 1 is played after stage 2 than after any other stage. The same is true for the sequence of stages 4 and 3, but is the performance better in absolute terms in stage 1 and 3? The results show that the player plays better in stage 4 when played right after stage 3 rather than any other stage. This may seem contradictory to the previous result, but in reality, if stage 3 is not played before stage 4, the player's performance in stage 4 is much lower, which causes big performance differential when he finally plays stage 3. In stage 2, the worst performances are obtained by playing stage 1 before. This is very surprising, because the 3 to 4 and 1 to 2 sequences show the same shift from a stepwise increasing tempo to a more continuous increasing tempo. The difference is that in 1 to 2, the tempo is synchronous, while in 3 to 4, the tempo is asynchronous with the gameplay elements. These results are very surprising. A synchronous tempo does not help the player. On the other hand, asynchronous tempo seems to help the player, while we assume the opposite. To verify these results, we set up a second experiment. The Tetris game, available at the same address as Tetris, has 2 stages, hinder and help. The player plays 2 levels with a synchronous tempo for hinder and an asynchronous one for help in order to perceive, without being aware of it, the tempo. Then, in the hinder stage, if the player is comfortable, the tempo starts to increase more regularly. If he is in difficulty, the tempo returns to a stepwise increase. In the help stage, the tempo increase changes on the contrary when the player is in difficulty. The goal is to maintain a constant level of challenge. We collected data from 19 cadets from the French Military Academy of Saint-Cyr. They were randomly assigned a stage and had absolutely no idea that 2 different stages existed. After the game, they had to fill out a survey as in the previous study. Each of them played several games. Altogether, they played a total of 50 games, but for some of them the hindrance was not triggered because of the player's poor performance. So we eventually kept 30 games. As we manipulated the tempo dynamically to influence the player performance, we cannot use the number of lines as a metric for performance anymore. An hindered player, since he makes more mistakes, will take longer to complete a line than another player. To check whether a significant difference in behavior could be detected between hindered and helped players, we also check the number of completed lines in relation to elapsed time, which is homogeneous at speed. Nevertheless, the influence of acceleration of the game should be taken into account. Game phases with a progressive or stepwise increase of the tempo can be separated in slices where the tetrominoes fall with a given frame per fall rate. We then express the acceleration with the following expression. This expression represents what the player is forced to impose himself to make lines disappear during one of the slices. We then compute the mean acceleration during a whole phase of the game. The results confirm our hypothesis. The variation of the tempo indeed triggers either a hindrance effect or else an help effect. The player achieves lines less quickly when the hindrance effect is activated. When the hindrance effect is deactivated, we see that the player recovers his performance. On the contrary, when the tempo is asynchronous, the transition from a stepwise to a steadily increasing tempo helps the player. It is also interesting to note the magnitude of the negative effect of removing the aid. The speed differential is significantly lower compared to the hindrance effect. If we now consider the acceleration differentials in the different phases of the game with stepwise and steadily increasing tempo, we can see a confirmation of the result. We observed an unexpected result. There is an interaction of the synchronism with the way the tempo is increased. This interaction can be used to dynamically vary the performance of a Tetris player. The origin of this performance variation remains unexplained. Players' feedback let us suppose that the tempo variation and synchronism have an effect on player stress. We therefore plan to continue measuring biometric data to test this hypothesis. We also plan to identify other sound and music criteria that could affect player performance. Thank you for your attention. Questions? Comments? Suggestions? Please do not hesitate to contact us and let us invite you to play Tetris.